Respected judges, I am Neelam Brand from Choice School, Kochi. My experiment today is going to be about total internal reflection with a density column. I will be making a density column using 4 liquids of different densities. Then, using a laser, I will try to study how the laser acts when it hits the boundaries between the different liquids. Before we start, let me explain total internal reflection with this diagram. When light passes materials of different densities, the light beam will be partially refracted or bent at the boundary surface. If it is at an angle called critical angle, then the light beam will be traveling exactly along the boundary. If it is increased higher than the critical angle, instead of the light beam passing through the boundary, altogether it will be totally reflected back. It is important that the light beam is passing through a denser medium to a rarer medium in order for this to happen. Let's start by making the density column. As you can see, we have 4 ingredients, going from the most dense to the left to the least dense on the right, from honey to oil. First we have to pour the honey. We have to pour all the liquids gently so that they form a nice density column. Now we have to pour the dishwasher soap. As you can see, they do not mix. It's because honey is more dense than dishwasher soap. Next we have water. This one you have to make sure you're doing it extra gently because this has a higher chance of mixing. Yeah, you can see the border between the dishwasher soap and the water. Now we have to add the least dense one, which is oil. As you can see, all of them have formed a neat and clear density column. Now let's try to get total internal reflection with a laser. We are going to do this on all of the layers. So let's start off with the honey and dish soap layer. As you can see, we have total internal reflection right here. Now we're going to move on to the next layer, which is dish soap and water. Right now we are only getting refraction, so I'm going to move the laser down slowly and try to get total internal reflection. I am afraid we won't be able to get total internal reflection on this layer because the density difference between the water and the dish soap is there, but it's not high enough in order for that to happen. So now let's move on to the next layer, which is water and oil. As you can see, we have total internal reflection right here. And now we're moving on to the last layer, which is oil and air. And just like all the other ones, except for the dish soap and water layer of course, we have total internal reflection. So, we have successfully had total internal reflection on all layers except for the dish soap and water. Thank you.